processes. Yesterday we looked at ammonia and industrial gases. You want to look at sulphuric acid, then fertilizers. I think it will be fine. So I want to look at manufacture of sulphuric acid. Sulphuric acid. Sulphuric has two spellings. American spelling itself, it's like this. And then we prefer this one. Right. So I want to teach the exam on this. What do they ask? So what is the name of the process?
Conduct.
Thank you very much. Name of the process? G. Conduct process. G.
Conduct.
Conduct G.
Process.
The name of the process is. They ask raw materials. Raw materials. What are the raw materials? Tine iron pyrites. Kanakutiji sulfur. Zimengwa, they can put sulfur dioxide. But basically, iron pyrites and sulfur. What is the iron pyrites? It's iron sulfide. And it is iron G sulfide. I want to put together on you that I can see and it. So, what else? The other raw material? Oxygen. Or simply A. Some call it G, A. When you say A, we are referring to oxygen. Those are the raw materials required for sulfuric acid production. Then from there, they may ask you source of what? Raw materials. Source of raw materials. Tinone P. These guys, Mamalia iron pyrites. You know, baby. From Buhwa. From Buhwa in Kwekwe. Altogether. Yes, Buhwa. But the spelling is Buchwa. It's Buhwa. Buhwa. Then we also, what about sulfur? Sulfur. Where do you get sulfur? In Zimbabwe. Do you have a mine for sulfur? I'm not very sure. Why I know it is usually, it usually comes from Canada. From what?
Canada.
From Canada. How do you get that? Then we have oxygen. You have said oral here, because it's oral here, we don't use both. Oxygen, where do we get oxygen from? Source of oxygen? There are two sources of oxygen. Tinachi, fractional.
Distillation of air.
Fractional, thank you very much. Fractional G.
Distillation.
Distillation of what?
Okay.
Distillation of G of liquid air. What else? Electrolysis of water. Electrolysis of water. These are the source of our raw materials. So, first, what is name of the process? It doesn't really conduct the process. First, what is raw materials which are used? Kumoma ziva tinechi iron pyrites, nechi ne oxygen. What else? You can say sulfur. Instead of G, iron G pyrites. Then what of the source of G? Iron pyrites from Bukwa mine. Source of oxygen. Either from water. Electrolysis of water. Don't say water. Put it right in the full. Electrolysis of water. Electrolysis of what? Of water. What is happening? Or fractional distillation of liquid air. Of liquid G. One of the two. Don't let it both. Together away. Right. What of them? My conditions. Necessary for the conducting process. Conducting process. tine chiyapa tine temperature nditi. What's the temperature? Yakafanana chi nehaba. Chizya 400
to 500.
Thank you very much. 400 chi
50.
500 degrees Celsius. Kureva kuti if you say 450 vanomaka nditi 480 vanomaka. Any figure between 450 and 500 vanomaka nditi. Maora. You can give us as a range. Or any figure between vanomaka nditi. Right. Sine muzama pepa wana nditi. They say 490 kuda kuvhiringa nditi. Yakanaka iwa nditi. Because 450 to G 500. Then catalyst. What's the catalyst? Yanzi vanadium 5 oxide. Anidi. Yanzi vanadium
5 oxide.
5 oxide. Pamanji vanadium pentoxide. But 5 pento means 5. Then temperature, sorry, pressure. It is usually 1 atmosphere. 1 atmospheric pressure. Those are the conditions. Tazvachi name of process, tazvachi my raw materials, tazvamai my conditions. They can ask my factors. I would get that. They can ask my factors. And what factor? What do? You don't specify the temperature. So factors affecting the conduct process. Temperature.
Catalyst.
Ani?
Catalyst.
Catalyst, thank you very much. I'll specify energy pressure. I'll just specify what factor. Another condition, what do? You specify the temperature, you specify the catalyst, you specify the pressure. All together. Then maybe they might ask you the roles of the conditions. Energy, temperature of 450 to 500 degrees Celsius. The temperature to speed up the reaction. All together.
Yes, sir.
Though the reaction is reversible and exothermic. To speed up the reaction. Though the reaction is reversible and what? Exothermic. And then they also, what about the catalyst of the vanadium 5 oxide. Catalyst to speed up the reaction. How? By providing a shorter reaction pathway and also by lowering activation energy. That's go. Could you speed up the reaction? How? By lowering activation energy and also by providing a shorter reaction pathway. Let's go. So don't you speed up the reaction by lowering the activation energy and providing a shorter reaction pathway. I don't know about the pressure. Don't know about the pressure. I don't know these two guys. Together we here. Tazvachi name of process. Mugarji conduct. Chikazamai my raw materials. Tikarji and pyras oroji sulfur. Nechi oxygen. Chikazamai my source of G raw materials. Tikar and pyras from G Bugwa. Tikar sulfur from G Canada. Oxygen from electrolysis of water. Or fractional distillation of liquid air. Tikazama my conditions necessary for the conduct process tikati temperature of what? 450 to 500 degrees Celsius. Pressure of G 1 atmosphere. Then catalyst of what? Vanadium 5 oxide. Can factors which affect G the conduct process tikati simply temperature, pressure, energy, catalyst. Tawenda by my rows of these of our conditions. And mainly they ask you about the temperature and catalyst. Temperature of 450 to 500 degrees Celsius speed up the reaction. Though the reaction is reversible and exothermic. Ideally, the reaction goes backwards. So we get low yield, but we get low yield at a faster rate. Those finally speeding up the reaction. Then catalyst in order to speed up the reaction by providing a shorter reaction pathway or lowering the activation energy of the reaction. How do you get guys?
Yes, sir.
So let us go to the next thing here. The description and explanation of the conductive process. In the previous syllabus, you had about 10 marks. What is it? 8 to 10 marks are it. As much as 5 marks are it. But the syllabus is now too long. Every syllabus are it. More questions than it. Right. So guys who can describe and explain, it means you have to give reason in some of the steps. And by explaining is usually only on these guys, the conditions. Explanation. So can describe the manufacture of sulphuric by the conduct process. So tell us the raw materials. And the raw materials used are the raw materials used are iron pyrites or sulfur and oxygen. Don't give us the source, please. Are you together?
Yes, sir.
Said by source. Then, what about what? Stage 2. Please name the stage. The first stage is called what? Roasting. In the roasting stage, roasting stage. In the roasting stage, iron pyrites is for sulfur is heated in the air. Is heated in what? In the air to produce sulfur dioxide. So in the roasting stage, iron pyrites or sulfur is heated in air to produce sulfur dioxide. How together? What is Java? The iron equation pyrites plus oxygen. Your arrow, we get iron oxide plus sulfur dioxide. That's what the question. Then, can I describe it? You get that? What the question or chemical equation? I will put it both for the sake of revision. So, what's the formula for iron pyrites? FeS plus oxygen is O2. Do you know what about the symbols? If you are doing, if it is combined, but for pure chemistry, you put set symbols on it. Yes, we get FO was iron 2 all together. Then plus sulfur dioxide. What are you balance? I know. and I can put
6 is 3.
I need 3 no I need. We need 2. What is it? 3 over 2 over 2. I need 3 over 2. It fetch over 3 I need. Don't know what about if you don't do pure chemistry. How do you get that? Let's go to stage 2 I need. In the oxygen stage. Oxygen stage in a one's way. In the oxygen stage, sulfur dioxide. Dioxide is oxidized in air to produce sulfur trioxide. The reaction is exposed to a temperature of what? 450 to 500 degrees Celsius to speed up the reaction. You know, this is your explanation. And the reactants or the reaction is exposed to 450 to a temperature of 450 500 degrees Celsius. To speed up the reaction, command it. Also exposed to G, catalyst of G, catalyst of vanadium oxide. Reason to speed up the reaction. And to a pressure of what? A pressure of 1 atmosphere. To stabilize. Stabilize the reaction. How do you get that? Those are, we explained here. What actually equation? Sulfur dioxide, you put your reversible reaction, what do you have? Vanadium 5 oxide. I can say with you 180 ml, then 450 degrees to 500 degrees Celsius, then sulfur trioxide. Trioxide. Then did the CHF oxygen. Thank you very much. The CHF oxygen, please. Plus oxygen. Normal.
Hey.
No problem. Thank you very much. Vanadium 5 oxide. 1 atmospheres, 450 degrees, 500 degrees Celsius. To get here, sulfur trioxide. And those stage 2. Then in the next stage, the stage 3, the absorption. You know the contact stage. In the contact stage, some say contact stage, or G, absorption stage. Then sulfur trioxide is absorbed in concentrated sulphuric acid. To get oleum and heat. Is very explain. Then you have to explain here. Why do we do this? This avoids. Okay, maybe we can say later separately. For example, we are too young for that. And then, for example, sulfur trioxide plus concentrated sulfuric acid. Then we put an arrow here, what is oleum. You can also put equations here, chemical equations here, chemical symbols. It's SO3 plus